Hi, my name is Ji Wan Chung, and for my project for this term, I chose to, implement this project called YouTuber recommendation with embedding algorithm. So you guys have seen me already, so I'm just gonna basically expand upon a few more information and also the progress that I've done so far ever since the first presentation that I gave regarding my project. So this is my table of contents. So I'm going to go over each of these points soon soon right now. So motivation. So basically, I chose to do this project because I have a huge interest towards recommendation system. It is something that I like to really focus on to, you know, later on when I can use my data and analytics skills to make like a huge impact or influence in the marketing field. So I have the motivation to test out like a new data set, and based upon the analysis from the algorithms, I like to observe how big data analytics can lead to CRM, which is the customer relationship management, which is one of the main goals of the recommendation systems. And for me, it will be an opportunity to investigate and test different kinds of algorithms, each of which which give different performances, and one leads to better performances than others. So my objective here is as shown. So starting from the left side is the data that I'll be utilizing. So you can see the data are twofold. Is one is the YouTuber data, and the other one is the YouTuber video data. And each of these data sets have their own the categories. And right now, the YouTuber data is consisting of the information for each YouTuber. So it's mostly about their age, the name, their ID. So basically their personal information. While each of their videos has information regarding the number of likes, the comments and descriptions, all those things that appear in the YouTube videos. And these data are categorized into different kinds of like products. Then as the data is analyzed, I will, you know, take the keywords of the each video list and also the hashtags, and based on the algorithm that I implement, I'll see um, how relevant the keywords are to the YouTubers data. So my goal is to see how the keywords are actually how well they match up to the description or the titles, and see which keywords are actually present in the videos. So Dr. Beck, this is the one. This will be one of the main algorithms that I will implement. So, I mean, I'm sure this is something that many of you already know. But Dr. Beck is basically just an expansion from the word to Beck. So, it is as it says on the title, is the document to the vector. So, it incorporates the whole corpus of information, textual information into the vectors. So, um, it basically adds like a new vector which has the paragraph ID into the word vectors, and Dr. uses like a cbow and the skipgram with additional feature vector. And Dr. Was found to be quite efficient in terms of text classification in comparison to BOW, which loses several subtleties of possible good representations, and also is better than LDA, which happens to be quite complex to implement. Um, you know, and it basically based on the distributed memory version of the paragraph vectors. So now the baseline and the dataset. So the dataset was obtained by this company called Uconnect, which is a consulting enterprise in South Korea that is dedicated to providing the best recommendation system for the YouTube creator. And actually, the company has done a great job so far in helping us. So far they've done their own research, and they've done their own like a coding by crawling the YouTube video data, and they actually decoded some of the unreadable data that were broken due to language issues. Like, for example, some Korean words were um, in a broken format because they will not be interpreted in some other computers. So they did a fantastic job with crawling the information that we need, and they actually organized the whole data set into structures. So we owe them so kudos for that. And they've done most of the crawling via Python. So so this is where they actually got the information from. So as you can see, each they took the titles from each of the YouTuber. They extracted the description of the each video, and also based on the comments that or their own comments of the YouTubers, they took the hashtags that are actually associated with the with the text over here. All the column names organized into the SQL database. Um, this will be needed later on. So and I will show that why as a project. And now on October 22nd, I used the Doctor algorithm again to see the congruity between the tag words and the video files. Sorry, video titles, and did the same to check the congruity between tag words and the video descriptions. And one interesting algorithm that I found that I thought could be useful is SimRank. Basically, it just shows, it gives the ranking of the most similar like congruity between this case it would be between the keywords, all the tag words, and the video information. So deliverables. So the data categorized into three main categories: the video extended, video comments, and the channels. Each data, every data provided in Excel datasheet format, and here are the tools that I used to implement this project. And one is the Python. And mostly, I use the Python to to implement the crawling and to execute the Doctorback. And possibly, I could use the C++ to implement something called GraphToBack. And as I mentioned previously, SimRank is something that I consider, so maybe I'll use that. But I could also use something called the semantic knowledge-based embeddings. Yes, so that has been the progress so far from my project, and hopefully I'll be able to make some great contribution and maybe spark some interest in the recommendation system for many of you. Thank you very much for listening, and have a nice day.